Alright, so we've introduced our bestest calculus friend, the differentiation rule sheet, and we've used him in a fair number of examples, and hopefully he's proved his worth to you. What I wanted to take a look at now was come back to some of the other rules on that first page with sort of like the broad principles instead of the specific formulas, because you may notice we've jumped over a lot of them at this stage. You may have also noticed that the examples I've done so far tend to end up leaning on those certain combinations of functions. So I'm only adding and subtracting. You might have noticed, well, why aren't we doing any multiplication or division? That's what we're going to be talking about today. So I've got listed here the case for multiplication first. We'll talk about division probably in another video, but so I want to take a look at what's the derivative of a product of two functions. So I have f of x times g of x here just to keep things nice and broad. But the first thing most students end up considering is, well, derivatives are limits, and we saw when we were doing our limit law stuff that we can break up limits across products, so maybe we can do the same thing here and take, f prime of x, g prime of x, and then just multiply them together. That would be awesome if it worked. Now, it turns out it's not actually terribly challenging to come up with an example that ends up blowing this up where we have to give up stuff we already like on our bestest friend sheet. But rather than just be super duper basic, I want to take a look at one example in particular to demonstrate why we need to do things a bit differently. All right, so we've got a couple of polynomials here multiplied together. The quadratic x squared plus 7, the cubic 4 minus x cubed. Now, if we tried to do that, let's just take the two derivatives separately and multiply them together, well, we have some constants. They're going to fall away when we compute the individual derivatives. This would give me 2x. This would give me minus 3x squared, and multiplying those together would give me, what, negative 6x, to 6x cubed. I've lost track there because you can tell how important it is to me. But in any case, we get one term once we multiply them together. We've got a constant times the power of x. On the other hand, if you try to do the algebra and FOIL this thing out first, I know that's kind of shocking that somebody would go that route, but just play along. So if we do that, we have to use the FOIL algorithm, and we're going to end up with, what, 4 separate terms here because nothing's really going to combine. We have an x to the fifth, we get an x squared, we get an x cubed, and we have a constant hanging around at the end. So we have a polynomial with 4 distinct terms, and only one of them is a constant. So if we were to take a derivative of the product, after we had done the multiplication, we're going to have 3 separate powers of x that appear instead of just the single power of x that we got when we multiplied the two derivatives together. So yeah, sorry, that thing I listed before, I put that slash mark through the equals sign. It doesn't work. Let's take a look at what does work. All right, so this is the broad strokes, like general rule from the bestest friend sheet. If you look, it's listed as number 4. It's called the product rule. It's a big deal. So you'll notice we kind of take turns calculating derivatives here. We calculate the derivative of f prime, but we leave g alone. We leave f alone, take the derivative of g. So we have f prime times g plus f times g prime. In terms of like mnemonics for this sort of thing, I had somebody at one point say the derivative of hi-ho was, ho-de-hi plus hi-de-ho, d being shorthand for derivative. Since you have the reference sheet, you don't really need to have a mnemonic, but, it's there. It's stuck in my head. Now it's stuck in yours. You're welcome. All right. So now, let's come back to this guy here. So I find it beneficial when I'm working through these things initially. I'm just going to go ahead and label these two separate guys, f and g. So the bestest friend sheet doesn't actually have all the of x's. It cleans it up a bit. I'm a stickler when I write this stuff down, so I usually don't take that shortcut. Anyway, so now if we take a look at this, so this says we need f prime of x. Well, our f function in this instance is x squared plus 7. The derivative of that guy, we kind of already said, is 2x. Then we leave g alone. This is particularly important. So this 4 minus x cubed, he just gets copy pasted, onto the, what we've got here. Repeating the process, now I copy and paste f, so Control C, Control V. If you don't get that, it's okay. Then I need to multiply this term by the derivative of this guy, which we said was negative 3x squared. And so now, if you want to clean this up algebraically, you can. fourth out of the first piece. Back here, we get minus 3x to the fourth minus 21x squared. And you can combine, these two guys to give you minus 5x to the fourth. And as it turns out, once you do that, that will line up with what our algebra fan would have gotten had they, worked out the derivative after doing the FOIL thing on these guys. All right. So it feels weird. I just confirmed that is the derivative we should get. I'll put my little "this is the answer" box around it, even though, technically, I'd really like to see you combine those terms, but, it's not worth erasing stuff on the board just for that purpose. All right, let's take a look at some examples that aren't just, polynomials, where we could have technically gotten around the product rule if we had just done the algebra beforehand. All right, so in this instance, I guess we've made things a little bit cleaner. We don't have any addition, but now we've got this cube root function sitting in front of the natural log of x. So again, we have a product going on here, so we need the product rule. Again, I'm going to label these guys. It's a little hard to track, but yeah, this is my f, this is my g for my product rule formula. And yeah, technically, just as a note, just as a reminder, we can take that cube root function and turn it into a fractional exponent. So this is really x to the 1/3 times the natural log of x. All right? All right. Okay. So now we execute our product rule formula. We need the derivative of this guy. Since it's actually x to the 1/3, we can use our buddy the power rule. So we have 1/3 x to the negative 2/3 times g without any derivative. So we get that thing times ln of x. Yes, if you wanted to undo the negative exponent, you could, but it's not strictly necessary here. All right. So then we have f left alone, so just x to the 1/3 again, times the derivative of this guy, natural log of x. And you go look on the back of the bestest friend sheet, the derivative of natural log of x is 1/x, or x to the -1st if you prefer. All right. Now, I will clean up a little bit of the algebra here, just because, that's kind of awkward just to leave as it is. We know how to handle that. I'm not going to do anything with this first term. So 1/3 x to the negative 2/3 times the natural log of x, plus, this is x to the -1st, that's x to the 1/3. If you add your exponents, we actually end up getting x to the negative 2/3. So if you like, you could technically factor the x to the negative 2/3 off and have 1/3 ln of x plus 1. There are some situations in chapter 3 when we start dealing with applications where you might want to go that extra mile, but for the purposes of what we're doing now, it's not necessary. All right, another example on deck. All right, another power function times something that isn't a power function. X to the 8th times e to the x. Same principle is in effect here. It's product, need the product rule, so yeah, here's my f, here's my g. I'm trying to make sure those don't look like exponents. That's just notation. I'd write it in a different color marker if I had one. Anyway, so h prime of x here, we take the derivative of this first guy, so we get 8x to the 7th, and e to the x we leave alone, e to the x, plus, now we leave the f term alone, so we get x to the 8th smiling back at us, times the derivative of g. The good news is, g is e to the x. What's the derivative of e to the x? That's right, student, it's e to the x again. It just kind of sits there and grins at you while you take a derivative, and nothing really changes. So, that's that. Done, dusted. So, again, I really like the exponential function, so you'll get that feeling. It saves me work and stuff. So, again, you could factor off an x to the 7th if you'd like, but I don't really think it, I guess an x to the 7th e to the x, but I don't think it cleans up that much. Again, there's some applications, but if all you're wanting to do is demonstrate you know how to get the derivative, that's what we need. All right, one more example, and then we're going to call this video, call it done, I guess. All right, you may be looking at this final example and saying, Professor Carroll, we don't need any sort of product rule here. Please remember, this is not cosecant times theta. Don't do that. This is cosecant of theta. It's one function. So, yeah, you're perfectly, not x, call it theta. If I change my variable, I should be consistent, right? So, looking at our bestest friend sheet, the derivative of the cosecant function is going to look like negative cosecant of theta, cotangent of theta. And now you may see why I put this up. So what if we needed our second derivative? Now, at this point, we have two functions multiplied together, so we really are going to have to jump in there and use that product rule formula again. So I'm going to call negative cosecant of theta my f, cotangent of theta my g. All right, so we've already said what the derivative of this guy is because we worked it out beforehand. So we have cosecant of theta. We actually get this cotangent of theta that we leave alone times the extra cotangent of theta that pops up, when you take the derivative of f. So we usually abbreviate that cotangent squared of theta. That c is really ugly. You may be wondering what happened to the minus sign. Just as a reminder, we had a negative out front, and then we took a derivative of this thing again, which produced another minus sign, so they went poof. Anyway, so now we do plus negative cosecant of theta, or just minus cosecant of theta. That's that. I'm working on that fg prime term in the back. The derivative of cotangent of theta is negative cosecant squared of theta. And again, we can clean this up a little bit. Technically, maybe, yeah. So if you wrote it out directly, it would look like that. This is my f prime, this is my g, this is my f, this is my g prime. And as it turns out, the whole thing kind of collapses down to cosecant of theta, cotangent squared of theta, plus, because we have two negatives multiplied together, cosecant cubed of theta. And again, yeah, I guess technically you could factor off the, cosecant, factor off a cosecant term, and you've got sort of like some squares, but I've probably done enough trigonometry to, scare some folks already. So that's that. So we've talked about products. Next, if we talk about multiplication, it makes sense that we're probably going to talk about division. Yes, that's where we're headed.